As you guys have seen, we're going to look at finding limits graphically and finding limits numerically using our calculator. If you want to follow along, the graphical limits we look at to begin with are going to come out of your book. This is a picture from your book. It's on page. Oh, you don't have a book. Never mind. Yeah. So you're just following along up here.
On page.
Okay. So you'll be following along up here. Again, like I said, everything and everybody in here I had last year. So everything we do today, we did last year, and it should be a review, and you should be comfortable with it. So we're going to look at them graphically, and then we'll use our calculators to find them numerically as well. So let's get started on 15. We have the limit as x approaches 3 of 4 minus x, and we just have a linear function, a graph of a linear function. What would my limit be in this case?
3.
1.
1. Now remind me, what is it we're looking for when we're finding a limit? We're looking for a y value, okay? And in this case, we're looking for the y value when we get closer and closer to the x value of 3. And remember, I need to look at it from the left and look at it from the right. So as I'm coming in from the left, as I'm coming in from the right, my question is, am I going to the same place? And if I'm going to the same place, what is that place? And that would be the y value of 1. So my limit on 15 would be 1. Any questions on that one? Okay. Now, if I'm going to the same place, does that place have to be there?
No.
No. Okay. So 16, the limit as x approaches 1 of x squared plus 3. What's my limit as I approach 1?
4.
Looks like 4 to me. Because here's 1. I'm coming in from the left. I'm coming in from the right. Am I going to the same place?
Yeah.
Yes. And that is 4. The y value of 4. Everybody okay with that? All right. On 17. Now on 17, what type of function is this? What's that called? Piecewise defined function. Very good. So that's a piecewise function. So on this one, we're interested in the limit as x approaches 2. So as we approach 2, do I have a limit? And if so, what is it?
2.
It is 2. Now, is 2 there?
No.
No, it's somewhere else. But that doesn't matter. Remember, all that matters when I'm finding a limit is what? That I'm going to the same spot as I approach an x value. So as I'm going to the x value of 2, as I'm going to the x value of 2, am I going to the same place? Yes. And that y value is 2. So my limit there would be 2. Now, what if I ask you for that? If I ask you for f of 2, what would f of 2 be?
0.
That would be 0. Because once the function value, we're looking for where
The actual.
Where the dot is.
Where the dot is. Okay. All right. On this one, we got another piecewise function. I'm approaching the x value of 1. As I approach the x value of 1, what am I looking at? I'm looking at a limit of 4. What is my function value of 1? My function value of 1 is 2. Good. All right, what about 19? My limit as x approaches 2.
Oh,
There's no limit.
1 and
It
negative
does
1.
not exist. Okay, why does it not exist?
They're not going to the same point.
I'm approaching 2 different y values as I approach from the left and from the right. On 20, limit as x approaches 5. Does not exist. What's my reasoning on this one? Okay.
Or if they're both going out, there would be one, right?
Well, you could think about it either way. You could think about it as my limit's infinity, or you could also say it does not exist. Okay. The reason why it does not exist, what they want you to say is that as I'm approaching 5, I'm either increasing or decreasing without bound. Whenever I increase or decrease without bound, that's when I do not have a limit. Okay. Now, sometimes we want to talk about what the behavior of my graph is doing. Then we're usually talking about it's going to infinity. Okay. But on a question that could be does not exist or infinity, where the answer could be either or, they're not going to give you one of those. Okay? They're not going to give you questions that can be foggy like that. 21, limit as we approach 1 of sine of pi x. What's my limit there?
0.
My limit would be 0. Limit as I approach 0 of secant of x.
1.
1. Any problems with that?
Reading the graph.
No lines.
The y-axis.
Okay, 23, limit as x approaches 0 of cosine of 1 over x.
X is somewhere down there in the middle.
What?
Zero.
Like what? 0.
Well, you can't. It doesn't reach how many lines.
What's my graph doing?
It's solidly compacting itself around that.
It's going like that.
It is, this does not exist, and the reason is because my graph is oscillating between two fixed values. This thing is bouncing back and forth between 1. And since it's bouncing back and forth between 1, it can do that an infinite number of times and never get to 0. So this one does not exist because it is oscillating between two fixed values. All right, 24.
I didn't know that was possible.
24. The limit as x approaches pi over 2 of tangent of x does not exist. What's my reasoning?
It's bound.
Increasing
Up
and
and down.
decreasing.
Increasing and decreasing without bound as we approach pi over 2. All right, 25. We want to find f of 1. What would f of 1 be? 2. What would the limit be as x approaches 1?
Does not exist.
Why?
They're not
Because
touching.
They're going to the same point.
We're approaching two different y values from the left and from the right. All right, what about f of 4?
Does not exist.
Does not exist or undefined. Okay, what about the limit as x approaches 4?
2.
It would be 2. Everybody agree with that? All right, 26. I want to find f of negative 2.
does not
Undefined.
Undefined.
F, or the limit as x approaches negative 2.
Does not exist.
Does not exist. Why?
Because
Either increasing, decreasing, without bound. All right. What about f of 0? 4. Limit as we approach 0. Does not exist. Why? Approaching two different y values. F of 2. Undefined. Limit as we approach 2.
0.5.
Looks like 0.5 to me, or 1/2. F of 4.
2.
2. Limit as we approach 4.
It's both infinity and
Right. Does not exist because we are increasing without bound. All right, now what if I went up here? Let's see, 0. What if I went up here on this 0 and I put that mark on that 0? What does that tell me I'm looking for?
from the left.
Limit as we approach from the left. So what would the limit as we approach 0 from the left be? 1/2. And then what if I changed it to a positive? What would it be? It'd be 4. What does the positive mean?
Right.
Coming in from the right. Very good. All right. That's what you need to know on finding a limit using a graph. Any questions on that part? All right. Now we're going to use our calculator to numerically find a limit. So make sure you got a calculator out. All right. So we're going to go to the home screen, and we're going to do this slightly different than last year. Last year when we did it with the calculator, I had you mess with that table. And it becomes a little bit difficult and tedious. There's another way I want you to do it. I think it's a lot cleaner. And it's similar to what I showed you yesterday. All right, first thing we want to do is check our settings. When we are in calculus, our settings always need to be in radian mode. So to check our settings, we want to hit settings. We want to do document settings, and we want to make sure our angle is in radian mode. Once you change it to radian mode, go down there and click make default. Okay, so we always need to make sure we are in radian mode. Grab one of those.
Are most of them already in radian form?
Probably. I hope they are. ones you, well, no, yours came from Coach Price. But I think the default mode is radian. All right, so let's make a new document, and we want to start off, if it's there, we don't want to save it. And we want to start off by adding a graph. All right, here's the first one we want to look at. First one we want to look at is the limit as x approaches 4 of x minus 4 divided by x squared minus 3x minus 4. So let's go ahead and put that function in our calculator. Now, since it's a fraction, how do I put a fraction in the calculator?
Control divide.
Control divide is correct. So control divide, we're going to put x minus 4 in the top. And we're going to put x squared minus 3x minus 4. And we're going to press enter. Now, I really don't care what the graph looks like. We're just putting it in there to make sure we have a function in our calculator. Now, I want to do control doc to add a new page, and we want to add a new calculator page. All right, now, if you remember, if I'm going to use my calculator to do it, and I'm approaching 4, I need to make a table of values. And what values do I want to use if I'm concerned with the limit as we approach 4?
3.9.
All right. Very good. All right, so I've got 4. On the right of 4, we want 4.001, we want 4.01, and we want 4.1. On the left, we want 3.999, 3.99, and 3.9. And to get those values, instead of using a table, we're going to do what we showed you yesterday. We're going to press the variable button. We're going to select our function, and then we're going to just put in those values. So I'm going to put in 3.9. I'm going to go back to the variable. I'm going to select the function. I'm going to put in 3.99, and I'm going to continue to do this. And I think that's much more efficient than messing with that stupid table like we did last year. What do you guys think?
Yep.
Yeah.
I didn't know where it was.
I think that works a lot better. So now, once I have these values down, I just write them up here. So 3.9 gave me 0.204. I got 0.200, 0.200 as well. We got 1.999 here, 1.996, or sorry, that's point.
Oh, so it's like,
0.199, 0.199, 0.196. So as you can see from that, what is our limit as we approach 4?
20.2.
Yeah, it looks like our limit is 0.2. And when we're doing these problems, don't go through all the work to give me that table and then not tell me what the limit is. The table does not tell me what the limit is. You must go up here and show me what the limit is to get it correct. Got that? All right. Get to work. All right, so let's go back home. Let's get a new document. We don't want to save it, and we want to add another graph. All right, this time we want to look at the limit as x approaches 0 of sine of 10x over x. So I'm going to do control divide. Control divide, I'm going to do, remember, the trig functions are underneath trig, so sine 10x, and we're going to put it over x. Press enter. I really don't care what the graph looks like, so we're going to do control dot And we're going to do a calculator. Now, this time we're approaching 0. So Garrett, give me the numbers on the right side of 0 that we want to plug in.
0.001.
0.001,
0.01.
0.01,
0.1.
0.1. Very good. Cole, give me the numbers on the left.
Negative 0.001, negative 0.01, and negative 0.1.
Very good. So we want to punch those in. So variable, and we want to start with negative 0.1. So that gives me 8.414, 9.983, 9.999, 9.999, 9.983, and 8.414. So as we should be able to see, what's my limit as we approach 0? Looks like my limit is 10. All right, so we looked at finding a limit using the graph. We looked at finding the limit numerically using our calculator. Any questions on using either one of those?